So I suppose some of you are probably sitting at home right now saying, what the heck? How the heck did you get these values? Again, because I will have given them to you at the start of class, or at least during class, the answers to the homework. So let's practically look at seeing about how I got these values. So let's just look at this point here. We are starting at that point there, our starting price is 35 and our starting quantity is 15. So, in other words, our P1 is 35 and our Q1 is 15. So we could, if I was in class, I would say half of you figure out what happens when we go from 35 to 40, and half of you figure out what happens when we go from 35 to 30. But I'll just do them both. So here, when we go up, P2 is going to be 40, right? And Q2, as a result of an increase in price, the quantity is going to fall to 10. And so then we can put this into our percent change formula. So elasticity is Q2 minus Q1 over Q1 times 100. All of that over P2 minus P1 over P1 times 100. Some of you may have figured out here that that 100 cancels. And so now the issue is in the bottom, we put in 35 for P1, 35 and 35. We put in 15 for Q1, 15 and 15. We put in 10 for Q2, and we put in 40 for P2. This is a negative 5/15. This is a negative, nope, this is a positive 5/35. I'll make some room here. Some of you could break out your calculators, but I actually find it easier oftentimes when dealing with fractions to leave them as fractions. So this would be the same thing. Negative 5/15 is the same thing as negative 1/3. 5 over 35 is the same thing as 1 over 7. Again, sort of a moving, right? You're hopefully following along. It turns out there's this clever tool that I like to use, which is dividing by a fraction is the same thing as multiplying by its reciprocal. So this is negative 1/3 times, we're dividing by a fraction, 1 over 7. That's the same thing as multiplying by the reciprocal. You just flip these. That's the reciprocal, 7/firsts, which is just 7. But what this ends up being is negative 7 over 3, or negative 2 1/3. So does it follow our law of demand? Absolutely, it's negative. So we got the right value. So that was going up. Now let's try going down. When we go from 35 to 30, again, our starting price is 35. Our starting quantity is 15. Same thing. Now, when we go down to 30, our new price is 30. And as a result of that change in price, we have a quantity of 20. So we go through and do some math here. We have our new 20 minus 15 over 15, our new minus our old divided by our old, times 100. The hundreds will cancel. All of this is going to be over 30 minus 35 over 35. This is the same thing as 5/15, which is 1/3. This is the same thing as negative 1/7. We divide by our reciprocal, we multiply by our reciprocal, and we end up with negative 7/3, which is the same thing as negative 2/3. So we get the same answer whether we go up or down. In this case, it's also negative. When we think in terms of absolute value terms, this here is elastic. We're getting a 2 1/3% response in quantity for a 1% change in price. Now, the book has a more complicated way of doing it. It's this midpoint method. That's also still going to be an approximation. You're going to want to, by the way, you want to make small changes, not large changes. If we went up by 1 unit or down by 1 unit, we would get a slightly different answer. Of course, if we really cared about accuracy and getting this precise, we would end up just using calculus. But so in my view, if you really care about accuracy, it turns out this is really easy to do with calculus. We don't have calculus, we're not using calculus, so I don't see a whole lot of value in making this more complicated. Again, I would just stick with percent change rather than the more complicated method. Now, if we go down here, let's look at this point right here. Let's see. We started at 35. Yeah, let's do a starting quantity of 35 and a starting price of 15. Now you might say, but wait, isn't that, those are the same values? So certainly we're going to get the same value. The issue here is a 5-unit change in price as a share of 35 is a smaller share of 35. Whereas a 5-unit change in quantity is a much larger share compared to 35. And so this is why, since we're in percent change rather than change, if we did this in change, just in simple change terms, given the straight line here, we would end up with the same values all the way along. But we're dealing with percent change. So let's try this one down here. We have a starting quantity of, let's do this one here. A starting quantity of 35 and a starting price of 15. And again, we could, if we were in class, we'd have a long discussion about whether we went up or down. Doesn't matter in this case. So let's try going up. We'll go from 15 to 20. So 20 is our new, and at a price of 20, we have a quantity of 30. And so we have a negative 1/7 over 1/3. And again, dividing by a fraction is the same thing as multiplying by a reciprocal. And so this is the same thing as negative 3/7, which is a little bit less than 1/2. It's definitely less than 1. So down here, we are in the inelastic region. The response in quantity, the percent change in quantity, is smaller than the percent change in the force that we were putting on. Again, hopefully that helps you figure out what's happening here. Now there happens to be one point here where our elasticity is equal to -1. We talked about this region being the elastic region. In other words, the percent response we get is greater than the force. Down here, we're in the inelastic region, where the response is smaller than the force that we're putting on. And we have one spot where we have unitary elasticity. Okay. So hopefully you understand, A, that elasticity is different between demand schedules. That's one way we can use this. It's also different along a given demand schedule. Each point is going to have a different elasticity. I suspect you understand why we care. Hopefully I made a convincing argument last lecture on why you would care about using elasticity to be able to discuss different demand schedules. And maybe you got a hint as to why the heck you care about this fact. And a lot of it boils down to the revenue for corporations. So corporations clearly care about elasticity. So if you think about what happened by, say, right here, where we're in the inelastic region, increasing price, it turns out, increasing price yields an increase in total revenue. Up in the elastic region, increasing price decreases total revenue. So for corporations, it's definitely going to matter whether we're in the elastic or the inelastic region. This year, the chancellor made a big deal about reducing prices for living in the dorm with the idea that that would increase revenue. In effect, what he was saying was we are up in the elastic region and by decreasing price, we're going to increase revenue. Now, why would that happen? Say that we're right here. Well, by reducing price, what happens? We lose that area there in revenue. However, we also gain that area there in revenue. And it turns out that this area here is larger than that there. So the amount that we gain is less than the amount that we lose. And we can keep doing this. So turns out he was wrong. Reducing the price actually decreased revenue from people living in the dorm, which tells us what? Tells us we actually were down in the inelastic region, assuming nothing else changed. Now, in the real world, my guess is a bunch of other things changed, and so that's probably not a completely fair statement. But if that was the only thing that changed, that would tell us by the fact that we see a reduction in total revenue, that would tell us that we were previously up in the elastic region. Sorry, the fact that we increased price and total revenue fell. Sorry, we decreased price and total revenue fell. That means we actually were down in the elastic region, whereas decreasing price and causing total revenue to go up would mean that we're up in the elastic region. So companies clearly care about this. It's not clear that they all calculate it. Small firms don't necessarily calculate it. Large firms do. I have a student, one of my former students in Iraq. She works for Lafarge, a major international cement company. And last I talked with her, she was spending most of her time trying to continually estimate the demand schedule for cement in the Kurdistan region, in effect, so that they could figure out where along this demand schedule they were. Right? Now, again, we're going to talk later about the fact that in order to engage in this pricing, you're going to need to have some form of market power. If you're the only movie theater in the market, you might be able to do this. However, if there's other substitutes out there, you have a much more limited response. As we're going to talk about later, you in effect, you end up being a price taker. We're going to need a more complex model for that. But it turns out that firms clearly care about this. Who else would care about this? Now, again, private companies, a lot of times what they do, small companies, a friend of mine runs a jiu-jitsu studio. One of the things that they do, they increase or decrease their prices, and they see what happens. Do they see an increase or a decrease in total revenue? Of course, as we're going to talk about later, companies do care about total revenue, but really what the people in companies and the residual claimants at companies really care about is profit. So this oftentimes is an iterative process. We increase price, we decrease price, we see what happens to total revenue, we see what happens to prices. Hopefully that makes sense. So we don't just care about being able to compare demand schedules, we also would care about where we are on a demand schedule.